Okay, we're working on a 2000 Lexus RX 300 with a 3-liter engine. I believe it's a 1MZ engine code. It's a no start. It was towed in. We brought the car in the classroom. One of the first things we did, of course, is crank it, see if it starts. I want you guys to pay attention to the way this engine cranks. That would be number one. Just listen to it. Go ahead and crank it. Okay, so clearly, when you've done this enough anyway, when you hear an engine that cranks that way, it has a compression problem. You can hear it. It cranks really fast. And one of the first things that you would think of is maybe a broken timing belt. I've seen hundreds of these, and that's what they sound like. Low compression is the direction that we're going so far. It sounds like it has low compression. Let's go to a compression gauge, and we'll pull one spark plug out, take a look at it. We've actually already done that. I'm going to move the camera over to the compression gauge, and let's take a look at that. Okay, so we have the compression gauge connected. We're in the middle cylinder in the front. And go ahead and crank it. Let's take a look at our compression. Keep cranking, keep cranking. Okay, good. All right, so that's confirmed by the way it sounds. It sounds like it has a compression problem. It does, in fact, have a compression problem. You see we have 50 pounds of compression on this cylinder. We did do some other cylinders. I'm not going to take the time in this video to show all of them. The 4 cylinders that we tested, the 3 in the front, the 1 in the back that we can get to, they all had about 50 pounds of compression. Okay, our next process that we chose to do for this vehicle is cam and crank relationship. We have a scope, so we have the ability of comparing the two and seeing whether or not we have a jump timing belt or jump timing chain. I realize on some engines it's very easy to remove the inspection cover and to take a look at those marks, but it's important to know how to do this procedure on a vehicle that you can't do that, especially on an engine with a chain that is not easily accessible. Ways of identifying a jumped timing belt or chain, we're going to do cam-crank relationship. So I pulled up the wiring diagram, and on this car we have actually 3. We have 1 crank sensor, and there's 2 cam sensors. This being a variable valve timing engine, the VVT sensor is actually a cam sensor, 1 for each bank. And so if you look at this right away, some fundamentals here. 2-wire crankshaft revolution type sensors are generally going to be AC sine waves. They're permanent magnet pulse generators, also known as variable reluctance sensors. So these are going to produce an AC sine wave is what we're looking for. If we scroll down here and take a look at these, one of the things that you want to be able to do right away is you want to be able to recognize some things on the diagram. So first of all, these dotted lines that go around here are shielded circuits. That's a shield, and what that does is that is going to take any electromagnetic interference or radio frequency interference, and it's going to ground those out. So one of the ways you can determine signal wires is by ones that have a shield on it. So these are unfortunately both circled, so we don't know which one the signal wire is on these yet. Let me zoom out one. I want to point something out to you right here, and that is this wire, and this wire. Those 3 are all shared on these sensors. So what we know by that sharing of wires, that's the sensor ground. The sensor signal wires are going to be the ones by themselves. So a very fast way to identify the signal wires, and we can tap into all 3 of these sensors. On this particular car, it's a little bit difficult to get to, so we're not going to do it at the sensor. We actually did it at the computer, and it's going to be these 3 wires. These are my signal wires, and if we follow those, what we actually did is we got a computer pin layout. We adapted to the wires at the computer itself, here and then here. So we got all 3 of these at the computer. I'm not going to show that process. We can do cam and crank signals another time in another video showing instructional how to do that. But in this case, let me show you the picture of what we got. So this is our waveform. This is our crank signal. And these are my 2 VVT signals or my 2 cam signals. Now, unless you have a known good waveform to go by, this is really kind of useless information as far as figuring out whether or not your timing belt is jumped. I want to plug a resource I use. IATN, International Automotive Technician Network, has a waveform library that you can access. Look up the year, look up the make and model and the engine, and guys like me will upload information to help other technicians out. And it is a great resource. We actually did a search on IATN. Unfortunately, on this particular vehicle, we couldn't find a known good waveform, a known good relationship. And so what it ended up doing is making this test really not very useful. So there's some other techniques that you can use to identify whether or not you have a jump belt or chain, and I want to show you another one of those here in a minute. Alright, this next step that we chose to do, and this is something that's pretty new to me still, and I'm still learning how to do this more effectively, but it's an in-cylinder pressure transducer test. And what this is going to do is we're taking an electronic signal, so we're actually using a compression test, but we're using an electronic converter. It's going to take that pressure, it's going to convert it to an electrical signal, and we can actually plot our compression on the screen. So that's what we're looking at right here. If you take a look at this one, this is the cylinder that we're connected to, and that would be a representation of near top dead center, or the peak of this would be the peak compression or top dead center in that cylinder. And this would be the same cylinder again right here. And there's a lot of theory that we can do with this waveform. You can plug in valve openings and closings. This is actually 720 degrees of crank rotation from end to end. Actually, the exhaust valve opens around here, intake valve opens here, compression stroke starts around here. Lots of cool information we can put in this. Our main concern though for this wasn't so much that, but we wanted to figure out where the spark was occurring in relation to the height of this compression peak. And so what we did is we brought in another channel, and because this is a coil over plug engine, what we chose to use is the coil primary current ramp pattern. So that's what this red trace is a current ramp. They turn on and turn off of the ignition coil. I know it doesn't look like a ramp, but you need to understand how zoomed out we are. If I were to focus on this red trace for a second and blow that up, you will see that this is in fact a ramp. And it is a normal looking current ramp. So that's not the debate here is, well, someone may look at this and say, well, that doesn't look like a current ramp pattern, that looks like a square wave. Trust me, it's a ramp, we're just zoomed out. Okay, so a little theory here with the current ramp would be that when the coil is turned on is when it starts to saturate, where we build this magnetic field. And when the coil turns off is where our spark occurs. This is when our primary current stops, it's where secondary begins. And so if you look at the waveform, that would be right here is where our coil is going to fire. Put that right in line with the peak of that compression, and what we know by looking at this waveform is that our timing, ignition timing anyway, is right where it needs to be. Okay, so this gives us a little bit of direction as far as we're looking for a jumped timing belt, a jump timing chain. This is a procedure that you can use on any car. In-cylinder pressure transducer, line it up with your ignition firing event, see where it occurs. Truthfully, what we expected to see when we did this waveform is we expected to see this red trace maybe way over here, and nowhere near the peak of this compression waveform, which would have confirmed that we indeed have an ignition timing issue, and then we could proceed and take the covers off and do the inspection as far as the belt or chain goes. But this is the kind of test that will give you some direction. Unfortunately for us, this didn't give us what we wanted, right? Our cam-crank relationship waveform, we couldn't find a known good for that, and then this one is showing us